So today we are going to learn about queues. Queue is another data structure. It is in a linear data structure where a collection of data is stored in such a way that first inserted item will be in removed first. So for example, when we queue in a ticket counter where we purchase some tickets, maybe movie tickets, there are various important features. Let's talk about them one by one. So the first one is in queue. So in queue means insertion of the data into the queue. Data is inserted at the end of the queue. Another is dequeue, where data is deleted from the queue. Data is removed from the start of the queue. So next one is peak. Peak means get the data from the start of the queue. That means we want to view the first item in the queue, first data in the queue without removing it. Okay. And one more feature we are going to implement today is display. That is print data without removing items from the queue. Okay, we are not clearing data from the queue as of now. We are only displaying the data. Okay, later on we will discuss about space complexity and time complexity. So let's first start with some understanding about how queue works. Okay, so I have created a simple queue here where we have two pointers, one is front and another is rear. So when we insert or in queue any element into queue, then first of all we have to check if queue is empty or not. So here we are using front and rear pointers. If rear is considered as if its value is null, that means the queue is empty. So in that case, we simply insert new node as rear and set its value for front and rear both as a. Okay. But if we have some value, for example, now I have a in this queue. Now I need to insert another value b. So in that case, what I have to do? Simply check if rear is null or not. So rear is not null. Now what we have to do? Need to make rear next as new element, that is b, here as b. Okay, so that's how we insert. Now the rear belongs to this position instead of this a. Okay, so that's how we do insertion, that is in queue. Okay, so now let's study about the dequeue. Understand about dequeue operation. Dequeue is removing of the item from the front of the queue. So front is this, we have to remove item a from this queue. For that, before that, we should understand and check if queue is empty or not. For that, we have to check if front is equal to null or not. If it is null, then we can simply say there is no element in the queue and we can remove it. We have nothing to be removed from the queue. Okay, if there is any element, say a, then what will we do? We return the data. We get the data in a temporary variable from the front to store that and return it into later. And front will be front next will be front now. Okay, so front next is this one. And for this part, we also need to check if front next is equal to null or not. If it is null, then we simply set front equal to null and rear equal to null and simply return this t item from the product program. Okay, so that's how queue is dequeued. Okay, now our queue is at b and c and so on. Okay, this is the tq. Now let's go to the peak. So when we do a peak, say we have this element b at the front and we have to check if there is any element or not. So first of all we check null is not front is not equal to null. If it is null, then the queue is again empty. Otherwise, we will simply retrieve the front data and return it. Okay, so in case of peak, we simply return front.data, return it. Okay, and we are not removing in case of peak, so we no need to do any these operations. Okay, last one is display. So again we have to check if the queue is empty or not. If it is empty, then again we will not print anything. If it is not, then we will create a loop, maybe a while loop, where we set a temporary pointer to start of the queue, that is front of the queue, and then keep on increasing through temp.next and print t.data for displaying of that queue variables. Okay, so now we have understand the queue and how it's processed. So let's go to code and understand how we can implement the queue in C#.NET Core. We have created a simple example for the queues implementation in C#.NET Core. Here again we are using node class where we have stored the data and the next node as its next referring or linking item. So we are using this node to manage the two pointers, that is front and rear of the queue. Okay, so in the queue class we have created front and rear. So let's jump to the enqueue process. So in the enqueue we have the parameter string data which we want to store into our queue. So for that we create a new node and assign the new node data as the data which is coming into the input parameters. We will check if queue is empty or not. So at line 17 we are checking if the queue is empty or not. If it is, then what we do, we simply assign the new node that we have created and set the front and rear to this new node. Now if there is some value in the queue, then what we will do, then we set the rear next value to the new node. That means if we are inserting a, b, and now we want to insert C after B, then B is next is C. So B is next, that means rear next is new node and new node next should be nothing. So we will assign it as null, and the rear now is the new node because C will be the rear node now. So that's how we will do the enqueue. Now let's jump to the dequeue. In the dequeue we have to remove the first element from the queue. So for that we have to check if the front, that is queue, is empty or not. If it is null, then this is empty. If there is any another element available besides the first element, then we will check. If it is not null, then we retrieve the front data, that is a, b, c, and then a is retrieved into this data and the front next is moved to front. Now if we have A, B and C, then B will be our next element, and if we have no other elements, the single element, then data will be front data, and we will simply set front and rear as empty and return the data. So this is the dequeue process. In the peak we have to retrieve the value of the front of the queue. So in this case again we are checking if the queue is empty or not. If it is empty, then we simply print like queue is empty. Otherwise we will simply return the value of that front element. So front dot data we are returning from this. Now comes to the display. For display we have to check if the queue is empty or not. Again we are checking this. If front is equal to null, that means it is empty. So here in this case we are checking, we are taking the front as in a temporary variable, that is temp node, and in the while loop here we are checking if temp is not equal to null, then we print the data inside that temp value and temp will be marked as next of temp. So that's how we will keep printing in the while loop until the queue is moved end of the element where temp is null. Okay, so this is how we do the display of the queue. So here I have created a simple example where we are inserting queue elements and dequeuing and picking. So first of all, what we are doing is enqueuing few of the elements A to E and then display the elements, and then we do a peak, then 2 times dequeue, then peak, and then display. There is another enqueue and peak display for verification if we are able to insert the queue elements at the proper location or not. So let's run this and check what will be the output here. Okay, so I'm running this program here and let's see what will be the output. And okay, it's taking a little longer. Okay, we can avoid these warnings as of now. Okay, so the program is printing here like queue implementation. It starts displaying it here and printing queue. We have done some enqueue of the elements and then displaying the elements. So A, B, C, D, E, so these are the queue which we displayed A to E, and then we peak. A peak is will be the start of the element, so A will be the peak element. Again we do deq for 2 times, so A will be removed, B will be removed. Now these two returns and printed. Next is peak. Now peak is the front element of the queue. Now A and B is removed, so C will be the next front element, so C is printed from the peak. Again if we display this, so we can check C, D, E again. Now we did an enqueue. Okay, and after that again we try with the peak. Now C is the front of this queue, so we get C, and then we did a display. Now C, D, E, F is a final display. So that's how we do the implementation of the queue, and I hope you are able to understand the implementation of queue in C#.NET. Let's discuss quickly about the space and time complexity and usage of this queue. So in our case, the space complexity is O(n), big O(n). Why n? Because the number of elements in the queue are considered as n, and therefore the space complexity will be n. Now if we consider the time complexity, the enqueuing of single insertion of the item is O1 and again dequeue is On, but when we display or if we do a clear queue, then On will be the time complexity, where n is the number of items in the queue. So therefore overall time complexity will be big O(n). Finally we can discuss about the usage. So there are multiple uses in the programming and in various life day-to-day life for the queue, like CPU scheduling and disk scheduling, where we have the shared resources, single shared resources. And suppose we have to do printing jobs for the printer, so the first provided item will be printed first, so there is also the implementation queue required. Managing website traffics, like the request comes first, should be processed first. Again we get the implementation of queue here as well. And one more example is media player playlist, where we have to play songs or media items as per the playlist, like first preference will be played first. Okay, so this is the overall implementation and queues data structure. I hope you are able to understand it quite better, and if you get some learning from today's lesson, so please like, subscribe and share.